4, 3, 2. I think there should be 20-second delay. 4, 3, 2, 1, and we are live. Oh, actually, we're live. I'm so sorry.
Oh.
People watching us, disregard the last 20 seconds because we are live. We are live with Virtual Jug right here.
That's not how delay works. Do go on.
Right. Yeah. Hi, everyone. My name is Nicolai, and I'm very happy to see you on Virtual Jug. Before we start and before I give the word to our magnificent speaker, who is obviously Nicolai here, laughing really happily there because of the setups and complications with technology. Let me first introduce the Virtual Jug and say a couple of words. I just need to find my Zoom here, and I will explain everything with the help of 2 slides. I have some slides. Share, play. Right? You should be seeing the slides. Hi, you see my face, one of the better pictures of me. My name is Nicolai. You can find me on Twitter by @life, and I work as a developer advocate for the GraalVM project, which is a high-performance virtual machine capable of running different languages in different environments. And if you haven't heard of that yet and haven't looked into that, you should. Just yesterday, we released GraalVM 19.2 with a bunch of new tools and improved performance and other goodies. So please check into GraalVM. Follow me on Twitter. No offense. You don't have to do that. But yeah, this is me, and I'm welcoming you at Virtual Jug. Another sponsor of Virtual Jug is, of course, Snyk. Snyk creates developer tooling that enables developers to scan their projects for no vulnerabilities in their open source dependencies. That is what Brian Vermeer, a developer advocate for Snyk, told me when I asked what Snyk does. So if you care about security, maybe look into them. And why I'm mentioning Snyk here is because they hooked us up with the wonderful Zoom webinar technology for this particular session. I know that you're watching this on YouTube, most probably, but we're using a little bit different setup than before. So if you experience any problems with YouTube or the video quality, please tell us about it. So today, we're going to have Nicolai Parlog, or NipaFX on Twitter. And he's going to talk about what comes next to Java. Java Next, new releases, Amber, Valhalla, and more goodies is the title of the session. And you can watch this on YouTube, or maybe you're watching this on YouTube a little bit later than currently. Leave us any feedback. Tell us what you liked about this. Reach out to Nicolai if you have any questions, and we'll be happy to communicate with you. If you're watching this live, then please join the Virtual Jug Slack and join the channel live session where we will have the discussion about this and where you can post questions to Nicolai. And I will try to monitor that to the best of my abilities and use the opportune moments when Nicolai is grasping for air and interrupt him and ask your questions when applicable. Also, of course, share the group and the session. And if you have any feedback, just reach us on Twitter. It's @virtualjug or @shalad. If you're watching this on YouTube and the quality of the video is not up to your expectations, please use the cog icon and increase the quality. I think it should go into 720p. So that is all what I wanted to say before we start with the session. So now you are back to watching me and Nicolai faces here. Nicolai, how are you doing?
I'm doing fine, thanks. Great introduction, by the way.
Right, thank you very much. Nicolai is, of course, the software developer extraordinaire. He's the trainer, he's a writer, he does streaming for his development sessions. I know, I've heard Nicolai uses Twitch professionally. And he's here, I'm not sure, much more professionally than I. So, but he's here. Nicolai, the stage is yours. Let's hear about the Java Next and new releases, what comes in, what are new features and the goodies and everything.
Sure, thank you very much, Oleg.
I can see your slides, all good.
I did the right thing. So first of all, to everybody who's watching this live, and if you are in the Slack, please leave a round of applause for Oleg and for the VJUG organizers for making this work. Apparently, so the technology behind this changed over the last couple of weeks, apparently, and it's always on our work, and Oleg and I have been sweating through this. If my sound breaks or my video quality breaks, then that's most likely on me, because my daughter is watching Netflix in the other room. That's the only way to keep her silent while I tell you about Java. There you go. Okay, let's have a look. Yeah, I said, right, Java Next, new releases, Amber, Valhalla, and other goodies. Graal could technically be one of those goodies, but Oleg already spoiled it a little bit there. So we have lots to talk about. The slides are already online at slides.codefx.org. On the right-hand side, you'll see Java Next. Click that, and you can see the slides on your own, and you can navigate. Use page up, page down for that, because it's two-dimensional. You will see what I mean when you try it out. We're going to talk about versions and features of the past a little bit to give you an impression of where they come from. Then we're going to discuss the new world that we're living in, mostly the release cycle, which OpenJDK to use, right? So which JDK to use, licensing, that kind of stuff, support. And then finally, we're going to look into the future, which what I roped you into this talk, into the session, Amber, Valhalla, and Loom. And yeah, let's start with versions and features. Let's go from Java 8 to 13 real quick. 8 was released in 2014, and free support for Oracle's JDK ended in January 2019. So if you're still on Java 8 and are not paying anybody, so if you're on Oracle JDK 8 and are not paying anybody, unsupported version right there. I should reconsider and consider changing to another JDK. You could switch to OpenJDK 8, which gets free support by the community at large, specifically by Red Hat, until 2023. But we'll talk a little bit more about that later. So the core of Java 8, surely Lambda expressions, streams, and default methods, and most people went crazy when Java 8 came out. It was the first release that I really noticed as something's actually changing in Java. I didn't notice Java 6 and 7. Both of them came out while I was away, and I didn't even realize that Java was changing. There you go. So 8 was a big change. Everybody was crazy over that. The question is, where does it come from, though, right? Nobody sat down and implemented Lambda expressions like a month before the release. No, that was a little bit longer work, and it happened. Actually, what you're seeing right now, the screen, contains a hint. You can only really understand it when you know what the hint is. It's Project Lambda. Project Lambda, led by Brian Getz, ran from end of 2019 to the beginning of 2014, all the way up until Java 8 was released. Everything orange is a link, project page, JSR, mailing lists, great talks. There were lots of material that you could learn about Project Lambda before it came out or right after it came out. But let's have a short look at the project itself. It started in the end of 2009, as I noted. And back then, it was just the idea that we're going to need some way to denote functions in a more succinct way than with these anonymous implementations of an interface. And you can see the strawman syntax there, right? It's like a hash and then int x, int y, and that's not all at what lambdas look in Java now. And it took about 2 years of trying and failing and new prototypes until the first draft review already pretty much contains what we ended up with. But from there, it was still over 2 years until more reviews were made, and there was a public review, and then a final ballot, and then until eventually Java 8 came out containing lambdas. And we can learn a little bit about how these projects work. These projects start with an idea, which is then evolved over time. That can take quite some time, but the process is fairly open in this sense. I mean, it's comparatively easy to observe the process. Let's go to Java 9. As Oleg mentioned, he's going to ask me questions when I catch my breath. That rarely ever happens. So he will just have to interrupt me, or just take a short, give you a couple minutes for each new section, or a couple seconds, so in each new section, to write a question. So if you have any questions about what happened so far, join the Slack, post it there. Let's go to Java 9. Released in the end of 2017, support already ended, as for most of the upcoming releases that we're going to discuss. And surely the core of Java 9 is the module system. And I'm not going to go into that here. I wrote tons of stuff about that, links to blog posts, also a book. And I want to point out that there is 40% off code just for this session. And it's not only for my book, it's actually for all the Manning books. So if you go to Manning, you can hit the link if you want on the tinycc/JMS link, or you can just go to the Manning shop. And if you enter that code, MTPVJUG19, you get 40% off. And you'll learn more about the module system, which is good because we can skip the module system itself now and instead talk about the project that brought it to life. And when I ask at conferences, so which project introduced Lambda expressions, barely anybody knows. But if I ask which project introduced the module system, very many people know that it's Jigsaw. Its name is well known, and probably not for the best reasons. Anyway, so Project Jigsaw was led by Mark Reinhold. It was a huge effort that took almost 10 years. Once again, tons of links there. The mailing list it's huge. It contains so many discussions. And there were great talks about Jigsaw. Starting as early as the end of 2015, you could get a huge amount of information. The 4 talks that are linked here are from Java 1, and they not only discuss the module system like from a few different angles. No, basically this is a 4-hour talk cut into 4 pieces. It starts with motivation and then the basics, then goes into deeper features of the module system, and closes with the discussion of why it's implemented the way it is and how it's even implemented. So there's tons of information there. And I want to point out that this is as early as 2015, so it's like 2 years before the release. So a lot of information about Jigsaw was out there early. And my goal of this session basically is to teach you about the projects that are upcoming now, so you can learn about them early while they're still in progress and give feedback and experiment with them before they're out, before the release of Java 14 contains a variant of value types that you can't agree with. Well, 14 won't contain value types, but you know what I mean, right? This is a great way to learn early about what's coming. So Project Jigsaw was announced by Mark Reinhold this way. It's on his blog. Sun's primary goal in the upcoming JDK 7 release will be to modularize the JDK, which we hope to deliver early in 2010. And this sentence is amazing because basically nothing worked out in there. Sun, well, that didn't work out. The JDK 7 release was not upcoming, not early 2010. It took longer. And it did not contain the module system, of course. And the module system that we eventually ended up with is not only there for the JDK, it's there for the entire ecosystem. So you can see that a lot of these things change. I'm not showing this to poke fun at Mark Reinhold, just to point out what we all know as software developers, that project changed a lot, particularly in this case. It took 10 years to come out. So keep that in mind when you see these projects. Now let's talk a little bit about Java 9. Java 9 was planned to be released 2.5 years after Java 8, so it already got 6 months of slack. But then it was delayed a couple of times because of Jigsaw. And then in May 2017, we had a review ballot. And I think I'm not putting things too strong a term when I say this is pretty much how the community handed the ballot. So the public review ballot fails in May. And a ton of people said, we voted no because we needed these things. And these things, whatever they are specifically, were really hard to implement. So there were a couple of feature requests that are no way going to be implemented within a couple months even, not talking about the 4 weeks that they would have to be implemented because the reconsideration ballot to be a bunch of reasons that no way could be addressed. And I was sure, I was writing the book at that moment, that it was all a stupid idea to write that damn book. And it's just not going to come out, right? Because if those people voted no for the reasons that they gave, then they're going to vote again in a month. They didn't, though. That was weird. A couple of people switched from no to yes for no, I have to say, technically speaking, for no apparent reason. So what we can learn about this, that these projects are subject to politics. They lead to heated discussions. And even while feedback is taken into account and requirements are adapted, this is not always as transparent as it could be. I mean, people like what I just said, Mark Reinhold is doing that, Alex Buckley, Alan Bateman, those were the 3 people who worked a ton on the module system, very publicly, visibly too. And obviously they have other things to do besides answering stuff on the mailing list. But still, it's weird when you come to the mailing list and say, I tried this, this is a problem that I had, and you don't get feedback for 4 weeks or for 3 months until somebody comes out and says, yeah, you were right, we actually fixed that. And it feels weird that there's no immediate feedback. So while this process works comparatively open, I think it could be more open, could be even better. And then finally, these releases can take a long time, and these projects can take a long time, and that can delay Java releases, or so it was in the past. Because now we're entering new land. We're entering Java 10, the first Java release that took 6 months of cooking before it came out. It's a short break to give you, if you have any questions, post them now. Other than that, let's get on with Java 10. So it was released in March last year, and you could get 2 updates. Last one in July last year. So, you're not running Java 10, I hope. So yeah, so what's the core of Java 10? Surely local variable type inference is up there. Application class data sharing, I would not say it's like a big core feature of Java 10, but it's a really nice feature, and I recommend to check it out if you're interested in improving your launch times. And now I'm sure Oleg is cringing somewhere. But yes, you can improve launch times by as much as about 20% if you use application class data sharing. So once again, yes, you're chiming in, Oleg? No, I thought I heard you there. Anyway, so
no, this is fine. This is fine. Please continue.
Okay, good. So again, about var, blog post, video, it's all up there. Let's not talk about that. Let's talk about where it came from. What brought var? Once again, there's a hint there. It's Project Amber, but we're going to discuss that later. So I'm going to skip that now. Go to Java 11. Released in September last year, Java 11 is the official long-term support release. And we're going to discuss a lot what that means later. Just now, free support by Oracle ended in January, together with Java 8 support. If you are an OpenJDK 11, you will get updates from the community at large, governed by Red Hat until the end of 2024. Right? So if you're in 11, that's a good release to be on compared to 9 and 10, which don't get updates anymore. So what's the big awesome feature in Java 11? Well, so we can do this. We can now throw a source file, a single source file at the JVM, and we'll execute it. And you can use that to write actual scripts, like with a shebang line and all. You can write actual scripts in Java, which is a whole lot of fun. Slight disadvantage that it takes like 300 milliseconds to launch the JVM. So, but still a nice thing that you can do that now. We have a reactive HTTP2 client, which is pretty great. And then we have Epsilon GC, and I think this is the only garbage collector that, well, leaving C++ aside, even I could have implemented, because it really doesn't do anything. It just collects garbage until it has to, and until it runs out of memory, then it dies, which of course leaves the question. It's great for performance benchmarks. So if you're doing in between collections just to keep track of everything, then it's amazing if you can now compare it to a garbage collector which is thus 0. Right? So that's a good way to compare overhead as comparing it to another garbage collector, right? That's one thing. The other thing you can use it for, if you're running high performance applications that cannot even stand a single collection, like you have to have 0 collections, and even stuff like G1 or Shenandoah cannot address your needs, then Epsilon GC has the advantage that you're not paying overhead if you're not having collections. So if you wrote the code in a way that it runs for 6 hours or a day or a week without a collection, then pick Epsilon GC, you're having 0 overhead with the garbage collector there. But other than that, it's not like a big thing that we all start using. And you can already see that Java 11, like, it's not exactly having you, jump through hoops to get there because, of all the amazing features. Quite the contrary, we could start feeling like being spoon-fed new Java versions every 6 months, right? There's a new one. Yeah, I got it. That's amazing. No language changes, no dev-facing features that are anything monumental. But that's a good thing. That's really important to get that. This is not a bad thing that Java 11 looks almost boring. It's good because we're getting releases every 6 months, and we can't be hyped like Java 8 and Java 9 every 6 months without losing our mind. So a release like Java 11, containing no fundamental, no monumental feature, and even just very few interesting features, that's going to be normal. And we're going to see the same thing in Java 11. It was released this March. I think 11.02 is already out, or is it 11.04? I think it's 11.02, right? It's already out, so there's no more update for Java 12. What's the core of Java 12? I would claim it's switch expressions. It's a preview feature only, but you can now use switch as an expression. And we're going to go into this a little bit because we're going to see it again later when we talk about pattern matching in the future. So what you can see on switch here is 2 things. The first thing is that the whole switch thing apparently gets a value, right? You see switch day and then the curly braces, and no matter what happens, it says like an if statement, go here, go there. And then we have the conditional expression in Java, or the ternary expression, how it's often called as well, which does not only go here or go there, but the whole thing then gets the resulting value and can be assigned or returned. And if you use it as an expression, then it has a couple new properties that are very interesting. Once again, hit the link if you want to know more. You can also use the new Lambda style syntax that I showed there, right? Case Tuesday, then there's the arrow to 7. It's easy to read, right? If day is Tuesday, then the result is 7. But you could have used the colon form here in the past. So you can use switch as an expression or as a statement, has slightly different properties. and you can use it with the colon or with the arrow, and those also have slightly different properties. And the most important one of the arrow is it gets rid of damn break, because there is no fall through by default anymore. Actually, there's no fall through at all, which I think is a much better decision to make than fall through by default. But 20 years later, it's easy to make that call. But anyway, so I'm convinced that the arrow form will become the default for everybody working on 12 or later. Also brought by Project Ember, by the way, which, yes, I'm going to cover that later, I promise. Let's turn to Java 13, which comes out in, 4 weeks or something. Once again, support will end in January. That's when the last release will come out. Update will come out. So if you're on 13, if you are on 12 or 13, you kind of have to move with the times. But we're going to discuss that later as well. What's the core of 13? Surely text blocks. This is a text block, which is, you could also call it multi-line string, which I think would be a more natural name. I don't actually know why it's called text block. But it's that. It's a multi-line string. So you start with 3 quotation marks and a new line. The new line is important. It belongs to the opening delimiter. Then you put your stuff there, and then you close it with 3 quotation marks, either on its own line or behind the last character. And that's not actually make a difference, because the way you see it on the slide now, the string will end with a new line character. Whereas when you put the quotation marks behind that closing HTML tag, then it will close with the angle bracket there. There's a couple nice things to discuss here, which we're not going to go into. Once again, hit the link if you're interested. Just quickly, it does a very clever thing to discern which indentation is because of the code style and which indentation is on purpose. So right now, HTML, the opening and closing tag, would have no leading white space, but body and P would have a tab each. Or sorry, body would have a tab, P would have 2 tabs. Or if you're preferring spaces, and shudders me to say that, but yes, if you're preferring spaces, of course, then space indentation is kept as well. So it does a clever job there. That's one thing to note. The other thing to note is there is no there's no variable and these are not raw strings, so you have to escape stuff. So, for example, if you want to put in a literal \n, then you might have to put not the control character \n, but the literal \n. You might have to put in 2. You have to put in 2 backslashes. You have to escape like you would have to escape in any normal Java string. For example, if you want to put a regular expression in a text block, then you would have escape all over the place. The only thing that you don't have to escape is the single quotation mark, because it's not special anymore. And that's quite nice, because if you want to type JSON inline, for example, then the single quotation mark is the thing that you would have to escape the most, and you don't have to do that anymore, and that's kind of nice. Yes, also Project Ember, man, these folks are productive, and we're going to get to that, as I said, later, but because it has even more stuff in the pipeline. You can basically see that Project Ember has been dominating everything starting with Java 10. Good, that was the recent releases and the upcoming 13 and those features. Once again, if you have questions about any of this, about if you want to know about any specific feature in detail, maybe we can take like a 2-minute detour and I'll tell you about that. Or other than that, I would now come to the new world.
Right, we have a question in the chat from Piotr. Hi, maybe Nicolai could switch his browser to the full screen, please. That's F11, if you don't mind. Thank you.
Oh, it should be right. Thank you very much. Good point. That was totally my fault. I should have done that earlier. If that's the only thing, though, then we can continue, right, Oleg?
Yeah, that's unfortunately the only thing right now.
No, never mind. Let's go on then. So, features and stuff aside, Java changed on a more fundamental level than what the language is looking like, and the whole the fundament of the Java ecosystem and community changed. And the new world we're living in that new world, OpenJDK is the new default, not Oracle's JDK. We get a new major release every 6 months instead of every 2 to 5 years. And only selected versions will get long-term support, and not all of them. And all of these 3 are quite fundamental. I want to discuss each of them in turn. Let's start with the OpenJDK. Before we get there, we even have to discuss what exactly OpenJDK is. Because it's a little weird. You would think OpenJDK is like a Java release or something, but it's not. It's really just a project and a code base. So it's an organizational structure that has mailing lists and stuff, and it contains this is still Mercurial, but it's going to be Git soon, most likely. Contains the OpenJDK reference implementation. Sorry, the reference implementation for Java. And that's also part of the OpenJDK, and that's it. What is not part of the OpenJDK is any kind of binary. OpenJDK does not offer any binary that you can download. There are people building from that code base binaries. Oracle does that and shows them on JDK JavaNet. Adopt OpenJDK does that and shows them on Adopt OpenJDK net. And other companies do that. We're going to see that in a second. And by now, all of them build from their variant of the OpenJDK code base. But still, there is no simple just OpenJDK release that you can download anywhere. I think the closest you can get is Oracle and Adopt OpenJDK's variants. Under the links shown here, because there's still also Oracle JDK. So Sun and Oracle's JDK, just having a look at the past, contain more features, particularly when it comes to tooling. For example, then JavaFX was only ever included in Oracle's JDK. So those JDKs used to contain a little bit more features. They were perceived as more stable, for which I have no indication that is actually the case. I know no fact that proves that, but that doesn't mean it's wrong. I might just not know it. And they were also perceived as being more performant. And this is only true in very limited areas. For example, the 2D renderer in OpenJDK, the open source 2D renderer that underlies JavaFX, Swing, and AWT, was less performant than the closed source variant in Oracle's JDK. And by now, there's a new open source implementation, better than both of the old ones, which is now in OpenJDK and thus also in Oracle JDK. Because particularly between 8 and 11, Oracle put in a lot of work to align their code base with OpenJDK. They cut a few things out of their own feature set that were not technically part of the Java standard, and they were hence not part of OpenJDK. They open sourced a bunch of tools. Some things were newly developed. The 2D renderer that I just mentioned. What's the guy's name? Because you would expect like the new thing that's open source in there that is better than the closed source and the open source variant that were there in olden days. I would expect that somebody like an Oracle or something gets done then, somebody gets paid for that, but that's not the name. Follow me on Twitter. I will tweet about this after the session because he's doing amazing work. He re-implemented the entire 2D renderer. I know not many people care about that much, but it's still important for Java on the desktop and for everybody who generates images out of Java because you use the same stuff there, the same code there. He re-implemented that basically in its own free time, and that's pretty amazing. So I want to give him a shout out. If I would only just have prepared his name. Anyway, so he helped together with lots of other people to align Oracle JDK and OpenJDK. So by Java 11, they are technically identical. You can just switch between them. And that's important to understand that an OpenJDK build and an Oracle JDK build, there's no technical reason to choose one over the other. The difference is the license and support model. Oracle builds an OpenJDK that I showed you earlier that you can download at JDK JavaNet. And that one is licensed under GPL with a class path exception. Right? It's free, like it's free as beer and free as freedom. Then Oracle JDK that you would download from oracle.com/long URL, that thing is fully commercial. Even from 11 on, you cannot use it in production at all, not even like the first 6 months or anything. So, but that means, and I'm not sure whether Oracle intended that 100%, but that doesn't really matter. The point we're now is that OpenJDK is the new default. Whenever you start something new, you should start by downloading OpenJDK from somewhere that I showed you earlier, probably from Adopt OpenJDK, and start with that. And then you should think about, do I need support? Do I need to show someone a contract? Maybe I'm working for a municipality or some federal state or something, some government that actually needs to see, like you have somebody that gives you support for that. Maybe you want to stay on old release. There are tons of reasons to go another route, but OpenJDK should always be the default to start with. We're going to discuss support later. Now let's quickly go to the releases. As I said, now releases are coming every 6 months, but that has not always been the case, obviously. In the past, the releases were driven by flagship features. Project Lambda, Project Jigsaw, these two were the ones that would have to be done before the Java release could come out. But also there was a goal to have a new release about every 2 years. And as a software developer, you can immediately see the tension there, right? That doesn't sound like it's going to work out very well. To have like both the feature needs to be done and a fixed timeline. Also, of course, budget is fixed. So there you go. You have all three things fixed, and that works perfectly, right? So Java 7 took about 5 years, then 8 took 3 years, 9 took 2.5 years. 8 took mostly that long because of the some security problems that happened. There were some security problems that were emerged while Oracle bought Sun that delayed that for a while. But then Java 9 was almost exclusively delayed because of Project Jigsaw. And the reason is essentially the same one that it takes us that we might bump a release if we're in a similar model like this one. If you know the next release is far off in the future, and somebody asks you how long you're going to take, you're going to say, like, look, it's like I'm almost done. Just give me a week. Well, JDK is more like a month. Give me more time. I'm going to be done. I promise. Let's delay the release. Let's not wait for 2 more years. And then, you do it once, twice, and 3 times. In the end, like now, Java 9. We could have had Java 9 without the module system.
Nicolai, hi, sorry.
Have known that Java 9 would take. Yes.
Sorry, there was some glitch with the sound. I'm not sure if that's me or you, but can you repeat at least maybe the last 2 sentences?
Yeah, sure.
Thank you.
So all I said was, it's a simple psychological effect. You don't want the release, your feature to miss the next release. What you want is, like, delay the release for a short amount of time, and my feature is going to be in there. If you do that often enough, then it takes a long time for the release to come out. And as you could see, the module system could have been in Java 10 with almost no delay, and Java 9 could have had a bunch of other features in there without the module system and be released on time. And that would have been much better, because there were a bunch of features already done in Java 9 that did not get released because of the module system. They provide no value. And this is particularly uncomfortable when you don't even like the module system, when you've been waiting for a Java 9 release for one of the features, for one of the APIs that it contains, and you've been waiting because of something you don't even care about. This also increases reaction time, right? It's really hard to put something out there from the JDK team, to put something out there for us developers to try, and then have like 2 or 3 years until the next major release. That's not a good model either. The projects, Jigsaw, Lambda, there's always pressure on them to be done by the release date, and that makes everybody grumpy. Like no developer likes to be put under time pressure. We don't like to wait for features that are done or almost done just because of something we don't care about, maybe. And then the management is grumpy because, trying to, force developers to get something done on time is not an easy job either. So if it hurts, do it more often. And this is very straightforward. Fixed 6-month release cadence every March, every September. Whatever is ready gets shipped. Everything else just doesn't. There you go. It's important to note, because some people have the impression that 11 is like the good, proper release, and 9 and 10 were basically just alpha and beta versions for that. 11 is different because of the support model. Well, it contains more features than 10. But other than that, it's the same as 9 and 10. It has the same quality guarantees. And you can say, well, every new release takes 6 months before all the bugs are shaken out before it works properly. That's fair enough. But that is also true for 11 then. So 9, 10, 11, they have the same quality to reach. And so there's, from that point of view, no reason to stick with one over the others. So the same goes for 17. 13 that comes out next month, that's not a beta for 17. It's a full major release with all the same quality that you're used to, or that you're missing in other releases, who knows. The upside of this is basically the inverse of what we said earlier. Completed features get out much earlier, and there's no pressure on anybody to complete a feature at any specific point in time. And the JDK team has much better chance to react to changes in the ecosystem and incubate features. And the last point is really interesting, because in the past, Java came out and was set in stone. Whatever was in there was set in stone, was part of the standard, not to be changed unless you could change it in a backwards compatible way. This is not the case anymore. With incubating features, there are 2 new concepts, and there's about a 3rd concept to be born. But the basic thing is you have incubator modules for APIs. So a new API could come out and then be refined over time before it's finally standardized. And the HTTP2 client that I mentioned earlier, for that exact model, it was released in Java 9, and then in Java 10, and then in Java 11 was finalized. And you have preview language features. Those are, for example, switch expressions in Java 12 and 13, because it was a preview in 12. They got a slight tweak in 13, so it's still a preview in 13. And then text blocks are a preview feature in 13. And that means in 14, they might be finalized, and then they're a proper Java feature. But in 13, they are still hidden behind command line flags. You have to use certain command line flags to unlock them, to start experimenting with them. And the goal is that whereas in the past, to try a new language feature, you had to download a specific early access build from some project. And that is, even though it's really simple, it's still not something many projects or developers do. With preview language features, everybody has these on their machine. The only thing you have to do to give it a try is basically to go into your IDE and select something in the drop-down box for your language level, or on the command line, you just add preview features. So I invite you to go and check out the links, particular preview language features, because that's way more common than incubator modules, and then experiment with these new things. It's very easy. It's very it's a lot of fun to try these things out, and then even give feedback if you have any certain concerns. These command line flags that I mentioned only keep them from proliferating. So you have you cannot accidentally use a library, say, that uses an incubator module API, and then when that module changes, your dependency becomes outdated immediately. That cannot happen without you agreeing by also applying the same command line flags. So it's just there as a safeguard. Now, let's come to long-term support. We've danced around the topic for a while now. What does long-term support mean? And to understand that, we have to discuss roughly how development of the JDK works. So as I said, OpenJDK is basically a project and a code base. And you can download the code there. It's in a Mercurial repository at the moment. Might be Git in the future. You can clone that, and there you go. You now have the entire OpenJDK code on your machine. And there are tons of clones. Each JDK release gets a clone. Each JDK project, like Ember or Jigsaw or Lambda, get their own project. Each vendor then has one or more of their own clones. So there are tons of clones around, but it's really easy, also not really easy, but it's easier to think about them as branches. It's not 100% match, but if we think of these clones as branches, then we get way closer to our daily development model as regular developers, because a new feature really is basically developed in a feature branch. Let's leave aside, it's basically a clone in a project, blah, blah, but we can think of that as a feature branch. And when it's finished or nearly finished, it gets merged into master. And then in that model, a release is also pretty simple. 3 months before a release, a branch is cut just for that. And then development continues on master, but all the bug fixes that apply to that release branch are then merged from master into the release branch. Straightforward, right? What we would do as well. Basically, it's a 3 month of incubation period to make sure that that this release has top quality. So if a bug or security problem arises, then this will get fixed. And usually a fix is developed in master if it applies in master, if that works, if the problem is still present in master. And from there, it gets merged into relevant release branches. And the word relevant is really the operating term here. We have to discuss what is relevant, what that means. Because what support for an existing version really means is somebody fixes bugs, usually on master, and then somebody merges these fixes into release branches. Now, of course, support technically means more. As I said, you get a contract and stuff you can show and sign and pay money for. So there's a lot more involved. But from a technical perspective, this is what that means. Somebody fixes bugs, and not only in master, but also in the branch of the release that I'm on. So, right? So what does Oracle do here? Oracle works on master in the OpenJDK, and it will merge all fixes into their current release branch. That means at the moment, that would not be Java 12 anymore, because Java 12 is already, CC will see no future updates anymore. So if there were a bug fix on master at the moment, it would only get merged into the Oracle, would only merge it into the OpenJDK Java 13 release branch, right? You didn't see me put the air quotes around branch, but yeah, that's what they would do, right? That's what Oracle would do. And then because Java 11 is long-term support, if you pay Oracle, they would take that fix and then also apply it in their own branch, or rather in their own clone, to their own LTS version. So if you want long-term support, really, particularly if it's for free, what's left to do is merging fixes into old JDK versions. Basically, everything else is already done. If that bug is present on master, somebody already fixed it. They already showed how to merge it from master into, say, 13. Now, all we have to do is merge into all the releases. And I think in many cases, there will probably be basically the same patch, because Java doesn't evolve that fast, right? Between 12 and 13, 11 and 13, there are tons and tons of lines of code that are basically the same. So many fixes will just apply, but not all of them. This is where real engineering work comes in. And this is basically where Oracle and some other companies say, and this is what we want to get paid for. We want to get paid for the added effort of merging fixes from master into an old release, and the potential actual engineering work that comes with that. You can pay Oracle for that. You can pay IBM and IBM/Red Hat for that. You can pay Azure for that. You might be able to pay other people for that I'm not currently aware of. If you know about them, you can tweet them at me, and I put them into the list or put them into the Slack right now. But what I'm saying basically is you can pay different people for this work, and they will give you contracts, and everything will be nice. Now, if you're like me, you like your stuff to be free. First of all, because I don't want to pay money, but also because I like the idea of open source development and the free software that can continue to live even under commercial competition. And that's basically the OpenJDK code base itself. And the community committed to give 4 more years of support for all the releases that Oracle named long-term support. So when Oracle says 11 is long-term support, initially that only applies to Oracle JDK. That only means that you can pay Oracle to get long-term support for their Java 11 release. It means nothing else initially. But then, of course, because Oracle is the steward of what Java, it has a lot of influence, and basically everybody aligned with that. And now you can, all the companies offer the same kind of support for 11, 17, 23, and so forth. Azul is a small exception. We come to that in a second. Anyway, Red Hat took up guidance to make sure that all of these fixes that are visible on the OpenJDK code base will get merged into 8 and 11 at the moment until the end of until 23 and 2024. Right, so you can rely on the OpenJDK code base being updated with security fixes until those points in time, and then you still need a binary, and you can download and adopt OpenJDK, and there you go. You really that's basically the entire 2024, and download it, for example, adopt OpenJDK. Now, Red Hat is not the only company offering free long-term support. There are other companies doing the same thing. Amazon Corretto, SAP with a SAP machine, Alibaba does that with Dragonwell 8, Liberica JDK from Bellsoft. There might be more than that. And I don't want to undermine the contributions that these companies may or may not provide to the OpenJDK code base. But I want to point out that free long-term support, I can provide free long-term support by just putting codefx.org on a splash screen. Well, I'm not sure actually whether the license allows that, but you get my point, right? In front of the OpenJDK code, and there I go. Because as I pointed out earlier, OpenJDK itself is basically automatically updating by the community, by Red Hat. These companies here, SAP particularly, and Bellsoft and Amazon, these are part of the community, right? Well, Amazon not that much yet, but I hope that they will become part of the community, and that means that they will contribute their own fixes upstream. So not the community, and Red Hat doesn't have to do all of them on their own. Amazon Corretto is particularly interesting because Amazon is such a huge player. As I said, it builds on OpenJDK as all the other ones do. And what they say is it contains additional security and stability fixes that Amazon developed over the use of Java on their cloud. And kind of makes sense that AWS might have higher requirements for the JDK, and so they might actually have some improvements there. And as I heard, as far as I know, that they're currently contributing a big patch upstream that I think has something to do with the security manager infrastructure or the locking infrastructure. I forgot the details. But anyway, I hope they do that. I hope that Amazon will actually provide these security and stability fixes and thus become part of the community. Corretto is updated quarterly. Basically, they have the same dates there as Red Hat has, which might not be a coincidence, actually. Now, the question is, will Java change too fast with the 6-month release cycle? The test matrix will explode. The ecosystem will fragment. There are tons of worries here. And if you're interested in those, I invite you to have a look at the slides. I will just cover the last one, that nobody will leave Java 11 behind. All the other ones, yeah, I think don't panic. None of this is a big problem. And there are good reasons for that. And I'm going to step over them. Everything works on Java 9 and 11 and 13. I'm too lazy to update this slide every couple of months. I want to go to staying on Java 11. Because that's kind of a thing that we're in right now. So I ask at conferences who are not representative of the wider Java community, I assume, I guess they're more cutting edge, on which Java release you're on. And you can guess that about 90% of the people will raise their hand at Java 8, and that's that. But then there are a handful of people, or a handful of percent, before 8 and after 8. And I'm really glad to see that the group that is after 8 is actually by now larger than the group that is on 7 and earlier. So that's good. And then most of that, like all of them, should be on 11 or 12 at this moment, right? Because 9 and 10 are not supported anymore. So I would guess many people will see 11 as the long-term support release, go from 8 to 11, which is totally fair, and then sit on 11 and wait for 17 to be the next LTS. And I would love for everybody not to do that. I would love for everybody to go to 12, 13 as they go. But there are a couple of risks, and we have to look at those risks closely to make this decision. So let's have a look. The real big problem for Java 12 to 16 is that there's almost no support. Nobody came out and said we're going to provide free support. We're going to, by the time, for example, nobody is saying right now for security fixes we're going to merge them into OpenJDK 12. Nobody said that, and it's very unlikely anybody will do that. As far as I know, the only commercial support you can get for this range from 12 to 16 is Azul, which offers medium-term support for Java 13 and Java 15. And that support's I think 2 years long. About 2 years. So it's not very long. It's medium-term, right? So that means when you're on 12 right now, you have to go to 13 because you're not going to get free support and you're not going to be able to pay anybody for support for 12. So unless you can do that yourself, you have to go to 13 or you will be on an outdated version. And now, why wouldn't you do that? What could possibly go wrong? Stephen Colborn wrote a long article, Should you adopt Java 12? And I shortened this title here. It's or stay on 11 forever, something like that. But never mind. So, and that article points a very bleak picture. And I want to make sure to point out that nothing that he writes is wrong, right? But still, after you've read that article, take a coffee break and then realize that most of what he describes come from building against Java 12. It comes from using the Java 12 compiler to create Java 12 bytecode and run on a Java 12 machine then. But all you need to have security fixes really is just to run on 12. You have to build against 12. As long as your code eventually works on Java 12, that's okay. So for example, you don't have to target Java 12. You don't have to create Java 12 bytecode, because if you would want to do that, you might have to update a lot of your tools. And then the question that Stephen poses, and rightfully so, are you sure you can always do that? Because what can still go wrong, even if you just want to run on Java 12, the problem that could still go wrong is deprecate. Well, you can probably remember the deprecated annotation because I skipped past it. I'm going to explain that now. Deprecated annotation got a new attribute called for removal, and you will see Java APIs being deprecated and then they will be removed. And then also unsupported APIs that most likely your dependencies might be using are also changed over time. So what that means is, well, Oracle does of course not arbitrarily deprecate any old API and then check how often it is used. It could still be rarely used, and you could be one of the rare users. So what could happen is that an API that you depend on or might be deprecated, or because it might already have been unsupported at this moment because it's internal, might shift under you or your dependencies. And also, let's see what could happen here. So the chance that this happens is quite low, but it's not really easy to predict. Unless you know your stack really, really well and you know exactly which Java APIs you're using, even like the weird parts of your application are using, it might be hard to predict whether this might hit you. But I would say over the entire ecosystem, the chance is very low. But if an upgrade indeed fails, if you are on Java 12 right now and you cannot make the jump to 13 because of one of the removals, then what do? You either stay on Java 12 and run an unsecured JVM, that's not good, or you downgrade to 11. I mean, from 12 to 11 is actually fairly simple, but imagine Java 14 contains switch expressions and text blocks, both as final features, which is fairly likely. And then you write code, and all the way until Java, I don't know, like a year, you write code, and then you cannot make an update. Then you have a year's worth of code using features that if you go back to Java 11, you have to pull out again. And like if you actually have to do that, that damage is potentially enormous. Now, the expected damage is chance times damage. And we said it's a small chance, but a potentially high damage. So what can you do here? How can you evaluate this for your own code base? The more up-to-date your code base is in general, the easier it is for you to stay with current Java releases, the easier it is for you to keep all your dependencies and all your tooling up to date, the lower the chance is that will happen. Because if you sit on well-maintained, updated dependencies, and if something does shift beneath them, then the chance is really high that they're still going to have an updated version very soon. And then you don't have that problem that you have to go back to an old release. Because it's mostly not our code, but our dependencies to do this sketchy stuff, the fewer you have, generally speaking, the lower your chance will be. And if you have a very small code base, right? If you're like in the extreme position, you have the microservice people basically say, look, if I don't rewrite microservices. I just write them again. I don't refactor. I rewrite. I don't think whether it's such a great idea, but if you're doing that, if your code base is that small, you can rewrite it in, I don't know, Ruby in a week, then there you go. The damage is basically not existent. So the more up to date, the fewer dependencies, and the smaller your code base is, the easier it is for you, or the less is the expected damage from updating. And that's why I would recommend that. Unless you have a large application with lots of outdated dependencies, I would say you can do this, and you will get a lot in return. You will get new features as they come out. You will be able to provide feedback. And I know this sounds ridiculous, but it does play a role. It is more fun to develop a code base that uses current features than uses 5-year-old features. And even though we're doing this for a living and not for a hobby, why not go to that other company where I can do this for a living and have fun at the same time? So yeah, I think developer productivity and developer happiness also plays a role here. So I would say, actually, don't panic. The new release cycle will not kill Java, as was posited a couple of people a year ago. My general advice is find a suitable upgrade cadence. Ideally, the development team, the management, and representative of your users come together and discuss what you think would be a good upgrade cadence. And then you pick whatever's best for you. Don't let anybody tell you have to go to every new release, or you have to wait 3 years for the next LTS. Make up your own mind and decide on your own. Whatever you do, I highly recommend build on each release. Even if you say, I'm going to stay on 11 for the next 3 years until 17 comes out, ideally your build pipeline is very easy to just duplicate for another Java release. And then maybe don't do it for every build, just do it once a night, right? But there's incredibly valuable information in there. What you don't want to do is take on a dependency by the time Java 12 comes out, you're still on 11 though, that by the time that Java 14 comes out, you're still on 11. Doesn't work anymore because it uses tons of internal APIs, but you don't know because you're still on 11, and you pile years of more code on that until you go to 17 and then realize, oh damn, I could have known this a while ago. So build on each new release, including early access releases ideally, to get the information that you need to realize early on that something changes and you need to react to that. You should ever only rely on standardized behavior, which is really easy to say and not that easy to implement in practice. But whenever you make like one of these decisions where you know how the JDK behaves here will shape not just this one class, but will shape the entire subsystem. Does it do X or does it do Y? What I usually do is I try out whether it does X or Y. And when it does X, I'm just going to rely that it does X, which might be fine, but that might also be an implementation detail. That behavior might not be specified. If it's one of these big decisions, have a look at the Java doc very carefully. Maybe even you have to look at the JLS. Maybe you have to ask on some mailing list. If you make a decision that shapes the code for months or years to come, be sure that you rely on behavior that is standardized and not just randomly the current implementation detail. The behavior of the current implementation that you're using. Every new Java version has a tool called JDepreScan. Run that over your code and will tell you what dependencies you and your API are using. Sorry, what deprecated APIs you and your dependencies are using. And then generally speaking, keep everything up to date as much as you can. Once again, it's easy to say, it's not always easy to do, but it is. You have to do it anyway at some point to update. And if everything's up to date, you might have a good chance of switching from Java 11 to 12 without even noticing any hitch. But more than anything else, don't be surprised by what's coming. You can already now know what is in 13, and you can always start guessing what is in 14. And that's what I'll discuss next. I want to discuss projects. So, Oleg, how are we doing? Are we any questions?
Yeah, actually we have, and this is the right moment to ask you. So they've been gathering some questions for some time, so I'm going to ask you a bunch, and then we quickly go through the projects, I think, right? So do you prefer, yeah, let's do this. Before we go to projects, I think this is the rather...
Yes.
So Sergey is asking, what ways do you think are there to support backward compatibility across several Java releases? I assume when you are working with your own code, especially when lots of Apache big data related questions still work on JDK 8, but not higher.
Okay, so Apache big data stuff, I think I cannot be of any specific help there. I guess, you know what people could always do, like, I guess they already tried, right? ask or look for a question on Stack Overflow. And if you think some expert on recent Java releases can help you, then just ask them on Twitter with a link to the Stack Overflow question. You can do that with me. I don't promise to fix to address every question, but that would be a good try. So specifically, I can't tell you much about any of those. If you have a stack trace, maybe I could. That's the one thing. The other question was, how do you keep backwards compatibility across several Java versions? I guess that means that the people who ask that are the same people like the team that I work in a lot, because we deliver code to our customers. So basically, we don't really have a lot of control over the JVM that they run that with. We can tell them what version we recommend, but of course, we cannot say it's just 11, and there you go, it's going to be 12 next week. So that would not be a good thing to do. So how can you keep a project compatible across several Java versions? The first thing is you can do, if you want, you can take control over the over the JVM that is running your project. You can use JLink to create a runtime image that is just for your application. If your application is modularized, you can even include it. And if it's not modularized, you can use Gunnar Morling's tool Modetect, which can fake basically modules for your application. And then you can use JLink. And then you can create a runtime image containing your code, your dependencies, the JVM code that you need, and you just ship that artifact, which is a single artifact, to your customers, and then they always run the JVM you built that with. That has the upside that you never have to worry about your customers updating anything. It will always be the version that you ship with. There's a downside, and it's always the version that you ship with. And if that version has a security problem, you better get out a new artifact fast, because otherwise, I would guess you're kind of culpable now, because you delivered the entire artifact to your customers and they have no chance to individually update the JVM in there. So it comes with a trade-off, but that's one way. The other way is that even necessary? I would think JLink is the second best solution. The first solution is to just stay naturally compatible with several Java versions. And what I did when we updated to Java 9, and then eventually to Java 11, most of the work that I did was cleaning out code that did stuff it was not supposed to do. It was updating dependencies that did similar things. And all of that I did on master. So I didn't do the compatibility. Sorry, I didn't do the update, on a separate branch. I did that on master, and that build was always running on 8 still while I was doing that. Most of the work that you have to do to stay compatible is not dependent on the version. Most updates will just, most new versions of Spring will still work on Java, 7 or 8, right? Well, actually, no, I think Spring 5 now requires 8, but it will not require 11 in a week, right? So most big projects have a wide span of compatibility, so you can use that there. If you're using new APIs, for example, if you're let's say you're a logging framework, and Java 9 brought this great API, which makes you explore the call stack, which you need to show, which method calls the log message. There's a much better API in Java 9, which is better to use, but also more performant. So basically, as a logging framework developer, you want to use that API on Java 9, but of course it doesn't exist on 8. And this will happen more frequently. Java 11 has a great HTTP2 client, so maybe you want to use that instead of some other thing that you might have used on old versions. And this is where multi-release jars come in. A multi-release jar allows you to write code that is only activated on a newer Java version and lies dormant on an older Java version. So what you're basically going to do is you write your code as if you're still on Java 8, but then you have a small part of your code that uses a Java 9 or Java 11 API, and then you can package all of that into a jar in a way that you will only use the Java 11 code on Java 11 or later. And that way, when you provide function, for example, when you deliver an application to a customer, you can say, look, we want to use this amazing new API on Java 11 because it makes everything faster, but we still want to be able to run on Java 8. Multi-release jars give you that tool. You can have customers update to 11 and profit from better performance, most likely, or safer execution or whatever, while it would still work on Java 8. So really what I would recommend to look into are multi-release jars, JLink, and other than that, mostly trusting your dependencies that they will have a large span of compatibility, because it's not like Java is going to throw out things like, it's not like list is going to change next week in a backwards incompatible manner, and there you go, it breaks everything. So like 90% of the code or 95% of the code that we write won't have to change for years to come just because Java changes. I hope that answers that. If not, ask again or somewhere else, Twitter maybe.
Right, thank you very much. Do you know if the long-term support releases will have the preview features, just like those smaller, more frequent releases?
Yeah.
Gert-Jan Hutt is asking.
Yes, I'm like I can't say for sure because 11, I would say coincidentally, but you might say on purpose, did not contain a preview feature. Although actually it's possible that preview features were only introduced for switch expressions for Java 12. I'm not even sure whether they existed before 12. Anyway, I posited a theory about that once where I said that I would guess that if that makes a difference at all, which versions in LTS, then probably it's going to contain fewer of those features. But I was corrected, I think, by Mark Reinhold, who said no. Technically, this is LTS is a purely organizational attachment or add-on to that version. Technically, 11 is just like 10 and 12, and 17 will be just like 16 and 18, and so they can contain preview features. Yes, that's what I was told, and it makes sense because you still have to unlock them, right? So I would say yes, they will.
Right. Rima S is asking, what is your take on preview versus the GA model? And in general, are they right in understanding that you would pick the latest version that is still LTS for your projects?
So we're currently running on 11. And I also want to convince our folks to go to a more recent version, but we do deliver a software to our clients that they then run on their machines. And the problem here is that it only really makes sense for us to develop against 12 and 13 if we can have that as a minimum requirement, right? Because we're mostly looking at language features to make us more productive that we want to do. But that would then mean that we require our customers to also run 12 and 13. And these customers, being big organizations, cannot just nearly decide, okay, well, these guys want 13, so we're going to run 13 for them. So basically what we're struggling with here is the update model of other large organizations that we only have very limited impact on. And so that's why we will most likely stay on 11 for years to come, which I really don't like. But the reason is not a technical one, and it's not within our company. If we would run the system on our own, because it would just run in the cloud or wherever, or on our own premise, I'm pretty sure that would update to 12 and 13. Yeah, because it's an old application. Don't get me wrong. It's almost 20 years old. It's comparatively big. It's not huge, but it's big. It's about 1.5 million lines of actual code plus white space and comments and stuff, and has like 100 jars dependencies. So it's not like that's an easy project to maintain, right? With all the things that I told you earlier, we would be more in the risky situation. But we managed the Java 9 update before 9 was out. We were in 11 3 months before its release. We could do this in the past. We can do it again in the future. And we see a lot of value in staying that much up to date. So if it would just be our own concern, yes, we would go to 12 and 13.
Right. Excellent answer. And it plays into the follow-up questions about, for example, Apache Spark not even supporting Java 9. This is exactly the situation you describe, I think, whether there is a large third-party entity that would move forward, and it kind of influences you to use.
Yeah. I mean, yeah, you can't do anything then, right?
Right,
absolutely. If you're stuck with a dependency that relies on an older version of Java, and there you go. That answers the thing for you. I mean, then there's no sense fighting it. I mean, Java 8 is a great release to be on. I have to say that, right? Java 8, Lambdas, like Lambda and streams are, they're not a new addition anymore, right? But they're still fun to work with. They're still making you pretty productive. 8 has great performance. You can either pay Oracle for support, or you can switch to OpenJDK 8 and stay on that for, as I said, until 2023 or something. So if there are strong technical reasons, like a core part of your application depending on something that doesn't work on, that only works on 8, then by all means stay on 8, right? There's nobody coming around with a gun forcing you to update. That's okay too. If you can live with at some point being at the conference the one of 5 people who raises their hand for Java 8. Well, no, kidding aside, that's okay. Staying on Java 8 is not a bad thing to do. If you get updates, right? That's kind of important there.
Right. I don't think we have any more questions currently. Let's maybe continue quickly through the projects.
Yeah. So what I want to say is, don't focus on versions in general. Like in the past, you could, ignore basically whatever happened in the background, and then like half a month before new release came out, you could lazily start Googling Java 9 features and stuff, and you would get nice content. That will change because nobody knows what's going to be in Java 12 until like about, I don't know, a couple months before it comes out. So that means like Googling Java 12 features will give you a nice overview after the fact. But if you want to know what's going to be in Java 12 like a couple months before the release, then the internet is basically devoid of information, which is because the reason for that is the shorter release cycle. And that means you should focus more on the infrastructure that delivers these features on projects like Project Amber and like Project Jigsaw and at JEPs. And that's a good thing because that brings us much closer to the actual development model. It gets us in touch with the mechanism that, or with the infrastructure that delivers these features, making it much easier for us to actually interact with it as well. So large features are usually developed in projects, and then smaller features are proposed by JEPs only. And we're going to look at a couple of things that are coming. Very important. The syntax ahead is totally made up. Sometimes for people at Oracle, sometimes just by myself because I think it would be better. So if the syntax is, if you don't agree with the syntax, then we're not in the right point in time to discuss that. That we're going to see that later. All right. So when Valhalla comes close to fruition, then we're going to discuss syntax. So there are many great projects in the making. Amber, Valhalla, Loom are the ones that I feel comfortable discussing. Panama is not about native code that I don't know much about. And then we have Metropolis, which I think contains Graal, right? Was Graal its own project? Anyway, Graal is also very interesting. You should check out that one. As I said, I'm going to talk about Amber, Valhalla, and Loom. Let's start with Project Amber. It has smaller productivity-oriented Java language features as a goal. It's led by Brian Getz, just like Lambda expressions, or Project Lambda was. Once again, tons of links. Already great talks out there. There are unofficial early access builds that you can try. Once again, I invite you to try this out. Hit the links, read a little bit up on it. There's tons of information there. And that way you can have a better feeling for what's coming. This launched in March 2017. And we'll see that already delivered a couple of things. But the underlying motivation is that compared to other modern languages, Java is not always considered to be as much fun. As I already said, that does play a role. Productivity and engagement does play a role. And Amber wants to improve the situation of requiring a little bit less boilerplate, give it a little more expressiveness and less, being less cumbersome in general. And as we already saw, it delivered a number of things. Local variable type inference in Java 10, switch expressions that are previewed in 12 and 13, text blocks in 13, all of these were already out there, and then there are more endeavors. Pattern matching, records, serialization are going to be overhauled, most likely, maybe. Concise method bodies are a fun little thing that is at the moment in the draft mode, and then maybe raw string literals. So let's have a look at these. Let's have a look at pattern matching. When I discussed switch expressions earlier, we already saw most of what's going on here. Switch has a value, there's this arrow syntax that that has no fall through, that kind of stuff. But what's new here is the case integer I at the beginning, and we're most likely be gonna be able to do that with if as well. If that comes to fruition finally, we're probably going to see something like if foo instance of integer I or something. And what this does, of course, here in the switch statement as well as there, of course it does a check, right? Is that thing actually integer? But then also assigns that to a new variable that is then declared as an integer. So for example, value is an object, but in the line case string s, string format, blah, 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 the s there at the end of that line, I could use dot length on that because s is a string. It's the same, it referenced the same instance as value, but now it's declared as a string. And this is often called, I think, is a flow analysis? I feel like maybe that's not the right term. But anyway, other programming languages already have that. If you do an if instance of check, a flow control, I think. Anyway, if you have to do an if instance of check in languages like Kotlin, then it will know within that branch that, yeah, sure, this is a string. That's what you just checked, right? Obviously, it's a string. Whereas in Java, you still have to cast. But what that really means is that the case thing there that at the moment can only compare to static values, that thing will get more powerful. This instance shows how you can compare it to type and see, is it of that type, and then can I please have that as a variable of that type so I can start using it. That's great. Maybe we can also have something like ranges. If you can have a switch over an integer, and then you might have a case that if it's smaller than 5, right, all the ones smaller than 5 would be covered then. That would be nice. What we will get, these more powerful conditions, will also be something like this, which is basically constructing something. I mean, you could do this without problem with polymorphism. So let's ignore that. Let's leave inheritance out of the equation. Let's have a look at how you can solve this with this pattern matching thing. You have an eval method which takes a node. Node is an interface, and there are several implementations of that. And what a node really represents is a small part of some arithmetic computation, right? You can, in arithmetic computation, you can have an integer node, you can have a negation, and list. In this case, you can have an addition, and that's that. So there are three implementations of this node interface. One of them is an integer node, one of them is a negation node, one of them is an addition node. The cool thing is here that this case statement basically says if node n is an int node that was created from the integer I, then give me that I and do something with it. In this case, the evaluation of that integer node that wraps 5 would be 5. So that's why it says arrow I. If you have a negation node, then it negates another node. So you would want to evaluate that node and then, put a negative sign in front of that result. And if you have an addition node, which contains a left and a right node, then you would have to evaluate those and then put them back together. The thing here that's really interesting is that you can deconstruct an int node and a negation node into its constituent parts. And we're going to see in a second how that's possible, because at the moment that totally breaks encapsulation. Why would anybody know how an int node or negate node is created? See that in a second. I work in a code base with a lot of visitor patterns, and it makes sense that it has a lot of visitor patterns, but it's also painful because it's always so indirect, and it's really hard to figure out without running the application what exactly is going to happen. So this is going to make a bunch of that code more readable, and it's in general a good addition to a language. But since I said earlier, right, you can probably solve this better with inheritance. There are new trade-offs then to be made. Let's discuss something else. We're going to see how that relates to this pattern matching in a second. Let's say you want to have a range that goes from low to high. And this is basically a Java bean, right? So what do? You create these fields and a constructor. And then let's ignore the deconstructor thing there. You create equals and hash code and toString and accessors and all that kind of stuff, maybe even setters. You do all of this. For what? Like, this is straightforward what you want to have there. You want to have a range that contains all of this stuff, right? It's basically a bean. And Project Amber is bringing us these records. If we get them, then these pure data carriers require no boilerplate. The thing that you see there, public record range from low to high, that's all you have to type. It's not sure how we get setters, because most likely we will only get getters by default, right? Because immutability and stuff. But this is great because there's no room for arrow and equals and hash code. If you add a field, you don't have to generate code, or you have to remember to put it in code that's there. If you want to add a field, you just add a field and everything else just works. But also, it makes Java more expressive. You can now express that idea that this thing is just a data carrier, not by writing a comment or just behaving in that bean pattern. No, you can now express in code what this is, and everybody who sees that record will immediately know what you mean by that, right? They don't have to scan the entire code to see, oh yeah, I think this is just a bean thing, right? The setters don't do anything interesting. There's no caching here. Okay, it's just a bean. No, you can just express it with that record. Now let's focus on the deconstructor. Because the interesting bit here is that a record is really just, it's just these fields basically and a bunch of code around them. So that means that a range is defined by these fields. And that means you could deconstruct a range into these two fields. And this deconstruction is essentially, I'm going back one slide to pattern matching, is essentially what you see here. Int node would have been a record in this sense, and it would have contained the information that it was created from an I, and it can deconstruct it into an I without losing any state. Because the idea behind records is the API for a record models the state, the whole state, and nothing but the state. It models the whole state means that there's no encapsulation, and it models nothing but the state means that it doesn't contain other information that it hands out. It just operates on its own state. And the deal here is you don't want encapsulation. You're fine with the API being coupled to the internal state, but you want to get that damn API for free without, having to write all of it or having it generated. We'll come back to that trade-off later when we talk about value types. Let's have a quick look at customizing records, because you don't want a low to be greater than high. So most likely you have to do something there, and this could be one way to look at it, right? You could probably apply something that attaches to the compiler that runs after the compiler, so you can check whether low is not higher than high. And then probably in setters, if you get a setter for free, you will most likely be able to override it. So it's not quite clear how this will turn out, but you will somehow be able to customize them. Starting with record, we could finally see serialization come to an end, because serialization apparently is not nice to work with. I don't like it particularly because it contains a bunch of invisible mechanisms that you have to know about. Like, how was that private method called again? where you can replace the instance that is deserialized with another instance? I don't know. I would have to look it up. And it's weird that it's there and that you have to know about that. So it's a weird mechanism overall. And that complicates every JDK feature for the JDK team and was the source of repeated security vulnerabilities. And the idea that everything can be serialized is probably not a good one, because there's a sweet spot for serialization. What you want to serialize is stuff that is just data. That's perfect for serialization, that you can just take apart, put into bytes, and then put back together. And we just discussed one thing, and those would be records that are a perfect fit here. So maybe serialization will get revamped in a way that only works with records. So you cannot serialize random objects, just records. It would automatically deconstruct a record graph. That would, the JDK API would do that, and then would pass data to some kind of serialization engine. And then we could provide engines which write to XML, JSON, YAML. Well, we could even write to the old serialization format if you wanted to. So there are tons of things that that we can pick as a back end basically for this serialization. But the main work is still being done by the JDK, and it builds on this idea of records. The good thing here is that the new mechanism would use existing mechanisms, visible mechanisms like constructors and deconstructors, and not use these weird out-of-language mechanisms that nobody really knows. Well, of course, some people know how they work, but they always have to put a lot of learning to learn how they work. And hopefully, it's much more maintainable for the JDK team itself, so they can finally stop and answering when being asked at some of these big conferences, what JDK feature do you hate the most, or which thing would you wish you hadn't done, or bunch of these kind of questions always get the same answer: serialization. It's so much of a trope that sometimes Brian or Mark would say, look, we already covered serialization, let's pick something else to hate on here. Another feature that we might see is concise method bodies. In this case, writing a list wrapper. So I implement the list interface, but I'm also wrapping another list instance. So for most of my methods, I probably just want to say, yeah, if you call me for the size, really you want to call list instance size. If you want to get an item from a certain index, you probably just want to pass this on to list and get the index from there. And if you favor composition of inheritance, you might frequently come into the situation where you're like, oh, damn, I have an instance of that interface, and now I have to basically forward a bunch of calls to that. And that code is very simple, it's very repetitive, but it's not always simple to see that that's all you're doing. And we might get these kind of concise method bodies where you can concisely express, yes, my size is just list size, and there's nothing else going on. And this way you could then express that in this Lambda kind of syntax maybe. And it's great, because if I see a block of these, I would then say, great, these are just forwarding. I don't even have to look at them. I know exactly what they're doing. So simple stuff actually becomes simple, and you have fewer lines, fewer empty lines, which sounds ridiculous, right? But it's good. Like if you can express the same thing in 20 lines, instead of in 20 lines, in 5 lines, without making things more complicated, without adding complexity. Here you just remove needless lines, but keep expressiveness high by saying size is just a forward. And then saving lines does make a difference, because then it's much easier to scan past code and understand what's going on. Finally, I talked about text blocks. Let's talk about raw strings. Raw strings means you don't have to escape special characters. So you can, for example, write a regex just like the regex actually written, like /+ and then \d. And the question is, hopefully, the question is, how can we express that something is a raw string? And ideally, we just get a way to mark a regular string literal. I used the / here, but it could end up being everything. It would be nice if you could just put a character in front or behind or whatever around the raw string literal and say, look, don't do any escaping. We don't need any escaping here. This is raw. Take it as it is. That was planned as a preview feature in Java 12. It was unmerged. We've seen the first half of that with text blocks. Maybe we'll see the second half at some point in the future, because apparently it's a little bit more complicated than you would think. And it would be really nice then if that applying this rawness is orthogonal to how many lines you want to have. You can have a string literal, you can have a raw string literal, you can have a text block, maybe you can have a raw text block just by applying the \. And then you can pick and choose whatever makes the most sense for you now. So in this case, for example, I want to have a name and a regex thingy. And yeah, so I have a regex in there, so I have an incentive to use a raw string. So I want to make this a raw text block then with a \ in the beginning. As I said, all the syntax is made up. Nobody knows where this is what's going to look like, but it would be nice to have something like this in the language. So yes, Project Ember does make Java more expressive. You have to have less redundant typing. Switch can become more succinct and more expressive. Multi-line strings. I talk about pattern matching, which builds on switch expressions, record, the new serialization mechanisms. Most of these things make Java easier to work with, easier to remember what works, and makes in general more expressive. But it does add more trade-offs. Do I use var or not? Is a text block the right thing or not? Is pattern matching a good thing here, or should I just use a regular if or switch or whatever, or even inheritance? So of course, there are more things that have to balance now, and that always adds a little bit of complexity to the language, just because there is no way to avoid that. That's it on Ember. If you have any Ember questions, put them in the chat now. I have Valhalla and Loom to come, and I want to ask Oleg, how much time do we have actually? I thought like 90 minutes would be safe. Is that true?
Hi. Yeah, absolutely. If you could wrap it up in like 10-ish minutes, that would be absolutely terrific.
Okay. Yeah, I'll try. I'll do my best. If I get over time by 5 minutes, hopefully I don't get kicked out here. So all the questions for Ember pile up. Let's go into Valhalla. Valhalla has a very unspecified mission statement: advanced Java VM and language feature candidates, which is kind of weird. It's led by Brian Götz and John Rose. Once again, tons of links. Launched in July 2017, so it's like more than 5 years old, and it's still going to take. I wouldn't be surprised if another 5 years. So this is a big one because it addresses one of Java's most fundamental assumptions, that everything is a class or everything is a model, right? That's everything is a class, everything is an instance. It's a reference to something else that's underlying the JVM, and it's baked into so many of its assumptions. And primitives have always been the odd ones out. Everything that you do in the JVM has to be done extra for primitives, basically. And that means if everything is a class, then everything is mutable by default. You always have memory access indirection, right? If you have an array of ranges, as like regular classes, as we had them before, what you really want to have is an array of ints, low, high, low, high, low, high. But what you actually get is an array of pointers to random locations on the heap that contain low, high. So that's the indirection. And because one range and one other range might have the same low highs, but are not identical, right? They are equal but not identical. You have to have identity. Identity for locking, for example, requires extra memory. And you can lock on everything. And that's not a good place to be in, actually, because it would be much more interesting to actually lock on something that is a lock and not on just any random string that comes running along. So wouldn't it be nice to create something that is basically like an int, right? It's a primitive, it behaves like a primitive. And with value types, at the moment, the fad is to call them inline classes, just because Brian said so. But okay, I will also continue to call them value types because I like that more. So there you go. You can maybe do something like public value range. You have a low and a high field there. They will be implicitly final. And then you also have to write everything else, right? Constructors and static factories, equals hash code to string, whatever you still want to have, you have to still write them on your own. Because what you get here really are enforced immutability, no memory indirection, no object header. So that means wherever you pass a range, you don't actually pass a pointer to a range, you pass a low and a high. You pass two ints. And a range cannot be mutated, just like the integer 5, sorry, the small int 5 cannot be changed to the small int 6. You can replace it, but you cannot add 1 to the small int 5 and then changing 5 to mean 6, right? That doesn't even make sense. It's even hard to understand what I'm getting at because it just doesn't make any sense. Whereas a big I integer 5, right, you can have two 5s that are actually different. You have one 5 and another 5, and they might be equal, but they're not identical. And you don't get this here. These are immutable by enforced, right, by the JVM and the compiler. They have no identity, thus they have no object header. There is no memory indirection. An array of ints is actually an array of ints, whereas an array of integers would be an array of pointers, right? So you get all of this, and once again, like with records, you make Java more expressive. You don't only get performance, you also get to express in code what this thing is, and this thing is just a value. It's not a class. It's not supposed to be mutated. Great things are like complex numbers, two-dimensional points, three-dimensional points, temperatures, or currency values. All these are great values. We say, look, a currency value of 10 euros is just 10 euros. You can make that 11 euros. You can replace it with 11, but you can't make the 10th thing an 11th thing. So value types have the mission to code like a class and work like an int. And the deal here is that you give up identity and mutability and self-references, but let's put that aside. You give up identity and mutability, and you get the flat and dense memory layout. So let's put records and values side by side, because these look similar. And I guess a lot of classes want to actually be both, and we might be able to combine them once we have both of these features, but they are not the same. The trade-offs are different. For values, you say, I don't care about identity and mutability, give me a flat and dense memory layout, which makes my code more performant. You also express something in code, which is nice, so you should not only see this as a performance consideration or performance improvement, but that's basically what it hinges on. You give up identity and mutability, and you get better performance. Records, you give up encapsulation, and you don't have to type boilerplate. Totally different trade-off. But as I say, I guess most of the things that don't need identity and mutability, I guess will also not need encapsulation. And then you get hopefully all of that in one fell swoop. Better performance, less boilerplate. There you go. Now, if everybody starts creating their own primitives, then a couple of things, then boxing becomes a problem. We kind of accepted that you cannot have a list of int. And that's okay, because int is mostly a useless type, so int is just a number, so that's good. But if you start putting business logic into these values, then if you have an array list of range, you really don't want that, because of generics and boxing, to end up being backed by an array of boxes around your range. Once again, ending up with an array of references. If that were the case, if you could have an array list, if your list or array list of range, even though range is a value, would be backed by an array of references, then all the cool things, all the performance you get for your value types break immediately once they pass generics. And you cannot really write good Java code without using generics a whole lot. So the whole feature would be either very, very confided, like you cannot use it with generics, or if you do use it with generics, then there you go, but you immediately lose the performance advantage. So that's really not an option. That's why there's the idea to specialize generics. You will be able to have an array list of range and an array list of int to be backed by these actual arrays around these primitive types or around these values, not a box around them. This will give you great performance and will work with your value types. And then we can actually have a list of int as well. That's pretty nice. If you put these together, then within the JDK, a lot of things change. You probably have seen not only optional, but what's called a double optional, or is that what's called? Whatever, I already used them. Or like the stream, the double stream, or the integer stream, or the long stream. These exist because because boxing would otherwise make streams over primitives totally unperformant. So that's why somebody actually sat down and basically took the entire stream API and re-implemented it once for int, and then once for long, and then once for double. And that's as crazy as it sounds. But this could go away, right? Ideally, primitive specialization, generic specialization would take that away and would allow us to create a stream over string, that's a stream over objects, but a stream over int, that's a stream over primitives. And there you go, get all the performance for free. If we do then our code base, generic specialization and value types, then we get to write more expressive code and having to make way fewer trade-offs between design and performance. Performance will increase, and not by little. Looking at our code base, I would guess like anywhere between like 10 and 50% of the classes in there are screaming, make me a value, make me a record. I'm just a stupid data carrier that needs no identity, that needs no API, no encapsulation. Just, make me one of these. And all this would make much faster, basically for free. You have to change code, of course, but you don't have to deform your code to get more performance. Finally, if your APIs only communicate with values, then they only communicate with immutable instances. And if you do that, then one part of your one subsystem cannot influence another subsystem by mutating shared state, which is a big source of complex bugs to hunt down. These APIs will become much more robust if you basically just exchange immutable messages, so to speak. So Project Valhalla will make Java more expressive, more performant with value types and with primitive specialization. And I think it's, from my point of view, it's the most thrilling project within the JDK at the moment. That was very wrong. Wrong button. There we go. Project Loom. Sorry. Let's talk about Project Loom quickly. Apparently, I have 1 minute left, so let's make this fast. The idea here behind is that you get fibers, and let's ignore the continuations. And let's ignore the tail call as well. So it's done by Ron Presser, who does amazing work here. There are official early access builds that you can try. He gave a couple of good talks. One as recently as at JVMLS, think it was Alan Bateman and somebody else giving that talk. They launched in January 2018, and they still have a little bit of work ahead of them, but maybe we get that before the next LTS. So as a motivation, let's have a look at a hypothetical request that comes into your backend. Some code has to, parse JSON, put into Java objects, do that, then query the database, which takes some time, and then process the data for the response, right? Parse the response from the database, put all of that into the REST response, and there you go. If you look at how well you're using the JVM, then you're doing really good for task 1 and 3, but for task 2 it's really bad. There's a whole thread that basically has nothing to do. So the question is, how do you implement that? The straightforward way to do that is to have one thread for each request and then just block on the database call and sit there. And then you have really bad thread utilization because you're not doing anything. And in that specific simple example, that database call is most likely to take way more time than everything else in that equation. You can do something else. You can implement with asynchronous APIs. Use non-blocking APIs with futures all the way down, which means actually all your libraries have to support that. But then you get great thread utilization, because then as soon as something blocks, it basically just sits in the background and somebody else gets the thread to use that. It's highly scalable. And while there are other reasons than performance to write code like that, performance is the main reason, and that makes code a little bit more complicated. You have to have higher requirements to dependencies because you kind of not have blocking dependencies. And then also it becomes hard to debug. Basically, it's a difference like debugging stream versus debugging for loop. Like debugging stream is not impossible. It's not like it's like you can't do it. You can. It's just a little bit more complicated because you're much deeper in a complicated API stack. Let's assume there were fibers. What's a fiber? Fiber looks like a thread to us, but it's handled by the JVM. That's the most important part here. And it's really cheap to switch, and it's ideally a low memory footprint, because with threads, memory is limiting factor, right? A thread takes about 1 megabyte of RAM, so how many can you have? Like 1,000, maybe 1 million, but it stops somewhere. Ideally, fiber will end up with a memory footprint in kilobytes or bytes. And if you end up in bytes, that means you can have 1 million times as many fibers as you can have threads. And that's pretty cool, because what you can do then is you can rely on the JVM to manage a couple of things for you. There will be a carrier thread pool in the background that does a couple of things. That runs these tasks. But the important part is that fibers, if they ever end in a blocking call, what they do is they yield. They don't actually block the thread. A fiber says, oops, the database request, I'm yielding. And then somebody else comes in and takes a thread, the carrier thread, away from the fiber, puts it back into the pool so it can do something else. And once the operating system comes back and says, look, this thing is done here, what it waited for happened, then the fiber is put back, the task basically is put together with a fiber into the thread pool, and then will will continue later. So let's have a look at the database request. What happens in a fiber when the request comes in? The JVM submits a fiber to the thread pool that starts doing that. It starts task 1, interprets the request, puts together the database request, sends the database request. When it blocks, the fiber yields. The JVM gives the thread pool back to the pool. When it unblocks, JVM resubmits that fiber, and then fiber continues. We're not going to look at how in detail, but the point here is you get great thread utilization because you've not wasted a thread anywhere really. But the code looks like it's just synchronous code. At no point in time will you be in a 10T call stack deep thing in some asynchronous library. You'll just see that call, that call, that call, and then that call, and there you go. That's just a normal progression of debugging this and of looking at stack traces. And if everything goes the way that the Project Loom team plans this, then ideally legacy code is before compatible. That means ideally Tomcat, for example, would just have a small flag where you say, look, don't give my application threads, give my application fibers. And then your application gets fibers, and then you can just add between 3 and 6 zeros to the then fiber count, not thread count of your application, and basically you just save yourself 999 out of 1,000 instances that you might have been running in the past, because you can, it depends on the actual thread utilization. But if your thread utilization of a typical web app is between 5 and 30% or something, I think Ron Preston mentions in one of the talks, so you could still basically have a times 20 speed up by this feature, ideally without doing anything besides a little configuration. But of course, real life is always more complicated than theory. We're using thread local functionality for a bunch of things. And what happens to thread local when thread does a different task for different fiber? Not easy to answer. We're going to skip how this continuation works. Let's just have a look at Loom. It makes threading more pleasant. A simple programming model, but great thread utilization. I'm also looking forward very much to that. And unlike Valhalla, I think we can expect this in the next very few years, like maybe 2-3 years. So in general, to know what's coming, pick a project that interests you. If it's not one of the three that I just looked at, look at the list of projects. I think I also link earlier in the slides where you can see a list of all the projects. Have a look at that, find something that interests you, and then look out for mentions, whether you're on Twitter or whatever social media you use. So when you read something like whatever InfoQ or Snick's blog or whatever whatever you were getting your Java news from, look out for mentions of that project. Maybe subscribe to the mailing list. And like if you want to get a little bit in deeper, and I can only recommend this, find early access builds and try them. It's fun. Like have a couple of friends over, like programmers most likely, but there you go. Have a drink, sit in front of a computer and play around with value types. It's not everybody's expectation of a great Friday after evening, but it was fun when we did that. And if you try something out, give feedback. Go to the mailing list, say we tried this. Particularly for Valhalla now, you can start using Valhalla. If you work around primitives, you can already use it in your code. So if you have a library or a project that, for example, crunches a lot of scientific data, you can already start like on a weekend or when you get paid for that, even better. Spend a couple of days at work, switch a couple of relevant types to values and measure your performance. Go back to the mailing list and tell what you discovered. This is amazing and important feedback that the JDK team is desperately waiting for. Remember back to Jigsaw. We could have given feedback as a community 2 years before Java 9 came out. Very, very few people did. A lot of the kerfuffle in the end could have been avoided if people would have looked into this sooner. Tell your colleagues about it, chat with them at the water cooler, make this a thing to talk about Loom. It's rewarding and it's amazing to stay that close to the development of the next Java release. And that's it for now. Before I give back to Oleg and before I'm taking more questions, I want to point out 2 things. I wrote that book. I mentioned that before, so I'm going to skip that now. Well, this doesn't fit on my screen. What's going on here? I'm organizing a conference in Karlsruhe in Germany on the end of September, and I really invite you to come. You can buy your tickets now. If you don't want to pay full price, reach out to me, and I can cut you a deal. But come by, it's going to be amazing. We're going to have Robert Scholte there talking about Maven, Simon Richer on the state of Java, showing you the features that I went by really fast in all detail. Mark Phillip, who's maintainer of Gradle, will talk about Gradle. Christian Stein, who's maintainer of JUnit 5, will talk about JUnit. Will be a blast. Come, and I'm going to take more questions from Oleg or anything else that you might have wondered about.
Right. Thank you very much, Nicolai. This was a great session. We looked at the Java history, the past releases, the new upcoming releases, the current versions, and the projects, and that was really good. I learned a thing or two. I refreshed my knowledge about some important things, and it was a great session, and I hope you enjoyed that. If you are currently in this Slack channel, unfortunately, I personally have to go, so there is I don't have time for the questions. But Nicolai is absolutely there in the Slack channel, so if you have any questions, type it there, and he will join you there in a minute and respond to them. If not, find him on Twitter. He goes by @NipaFX and ask all the questions there. If you're watching us later on YouTube, subscribe to the YouTube channel and find me or Nicolai and ask your questions. We'll be absolutely happy to respond to you. Thank you very much. Thank you, Nicolai. It was great to see you again.
Thank you too for the opportunity.
With your conference and good luck. Thank you, everyone. Bye-bye.
Bye.